Welcome back, everybody. This is Ripley. All right, now we've got some terminology, we got some vocab, we got graphs, we know some brick and mortar terms like standard deviation and mean and how to find them. We got variance. Now we can start playing ball a little bit. Excuse me. I'm going to show you something here, but I'm going to make up some statistics. These may or may not be accurate. I'm sure they're relatively close. I'm going to say, let's talk about women's heights. All right, and I'm going to make a claim here. I'm going to make a claim that women's heights are normally or bell-shaped distributed, and that they have a mean, a population, notice it's lowercase Greek, of, let's say, what's it, 5'6"? Is that fair? Ladies out there, yell at me if you think I'm wrong. 66 inches. And let's say that they have a standard deviation. So remember, we're talking population here of 2.5. And then we're going to have men's. I think the apostrophe goes in the other place, but I don't know. I'm no English guy. Men's heights. And let's see, I don't know, 6 foot, let's call it 70 inches. So we'll say about 5'10". That sounds about right for average, huh? 5'10", 5'11". Let's go 71 inches. But our heights are kind of all over the place. And we'll say that this is a little bigger of 4.5. All right? Now, I am 6'1", and my girlfriend is 5'8". All right? So my height, I am 6'1", so what's that give me? 73 inches. And my girlfriend, so GF, now this is a sample of one, so we're not getting fancy here, but we want to know who's got bigger bragging rights. What did I say? She's 5'8", so she's what, 68 inches? Okay. I want to know who's taller in their group. In other words, am I taller amongst men? Clearly I'm taller than the mean, and I'm taller than she is, but I want to know if I'm taller amongst men than she is amongst women. Okay? Now you're going to have to forgive me for a sec. I got to sneeze. And I'm, oh, wow. Everybody should say bless you. Come on, man. Say bless you. Okay, thank you. There's a fantastic tool, and it's so elegant and so easy to use. It's crazy. It's called a z-score. This is a z-score. Z-score. Sometimes you'll hear this referred to as the standardized score. And I'll try and discover what it gives us in just a sec. All right. What I'm going to do is the formula for a z-score is either, if we're talking about a population, it's x minus x bar over s, or did I say population? Excuse me, sample. If we're talking about a population, then z equals x minus mu over sigma. All right. Notice there's still just, these are the means, this x bar here, and this mu here are the means, and s and sigma are the standard deviations. So what I'm going to do is I'm going to find my girlfriend's z-score, and I'm going to find my z-score, and let's see if we can interpret what that means when everything is said and done. So this is going to be z for the GF, and this is going to be 68 minus 66 divided by 2.5. Which is what? 2.5ths, affectionately known as 0.8. My z-score, so this is z sub n, is z sub m, is 73 minus 71 over 4.5, which is 4.5ths, which is what, 4/9, so 0.444. Now, let's look at what this really is, because this number is pretty, I should probably put an equal sign there, speak the language of math, right? What this represents is that my girlfriend's, I'm going to change colors, my girlfriend's height is 0.8 standard deviations from the mean. In other words, within the population of women, her height is is exactly 0.8 standard deviations above the mean. Now, meanwhile, over here, apparently shorty, I am only 0.44 standard deviations. In my group, I'm 0.44 standard deviations above the mean in my group of men. from the mean. So who's taller amongst her group? Well, as she will probably argue, it's her. All right? So that's a wonderful way to compare groups that have different means and different standard deviations. You know what I mean? It's no pun intended. I mean, clearly, I'm taller than she is, but relatively speaking, if I'm looking for relative standing, she's much taller in her group than I am in my group. That's pretty cool, huh? Right on. All right. Well, we're talking about standing, like comparative standing. Something needs to be addressed because you see this in all statistics books, and you guys see it all the time. Of course, we're talking about percentiles. So if I talk about percentiles, and the easiest way to describe it, percentile, if you haven't seen it before, let's say that I'm in the 90th percentile in height. This implies, so this is, wait, I don't want 90%. I want 90th. 90th, sorry about that, 90th percentile for height. This implies that 90% of everybody is shorter than I am. Okay? If I'm in the 32nd percentile, 32nd percentile for IQ. IQ, this implies that 32% of everybody is dumber. That's not the politically correct way to say it. Let's try that away. Try that another way. Has lower IQ. Has lower IQ. However, conversely, if you think about that, that also implies that what? 68%? 68, I'm missing an 8 in there. Whoops. 68% of everybody has a higher IQ. So you can read it both ways. Okay? So you've seen percentiles before. The easiest way to figure out what percentile a data value is you simply take, you let x equal the number of data values below a certain value. Okay, and you take x divided by n. Remember, n is the total number. Whoa, my pen's starting to get a little crazy. Total number of data, and then you multiply it times 100%, and that gives you your percentile. This is equal to percentile. Okay. All right. Now, there's a statistical tool lately called a box plot or a box and whisker plot. All right, and you may have seen this before, and these guys look like this. What you'll get is you'll get a box, and then you'll get a value inside the box, and then you'll get something that looks, I don't know, maybe like this. And then down here will be numbers. This is, by the way, called box plots. Okay? Now, you'll have numbers down here. So let's say that this is 1, and this is 5, and this is 12. I'm just completely making these up. Clearly, my scale is a little bit janky, so bear with me. Let's call this 18, and let's call this 25. What we're looking at in a box plot is real simple. All right? We're looking at the minimum value of the data set. That is on the left. This would be the maximum value of the data set. That's on the right. Now, this is called Q1, or the first quartile. The first quartile represents the 25th percentile. Okay? This guy right here, as you can well imagine, I'm going to change pen colors on this so you can see it. This is the median. All right? If you think about it, the median represents the 50th percentile. Okay? And then over here, we'll change back to black. This guy over here this is Q3, which is the third quartile It's crazy because they use all these different names for the same thing. This is the third quartile or the 75th percentile. Okay? So this group of numbers, the min, Q1, the median, Q2, or excuse me, Q3, and the max is called the 5-number summary. 5-number summary. And it is what is used to build a box plot. Now, I want you to notice something about a box plot. I have no idea what n is. I have no idea how big my sample is that created this box plot. Not a clue. I don't have a clue. But I do know what the min, the first quartile, the median, the third quartile. You could also think of the median as being Q2, sort of parenthetically speaking. If we wanted to think of it as Q2, we could. What Q3 and what the max are. All right, now I'm going to show you the power of a box plot here in just a second. But what I'd like to do first is I want to take you through a quick and down and dirty little way to make a box plot and a 5-number summary. And again, you'll be able to do this on your calculators. It'll spit all the values out for you, and it'll actually give you the box plot as well. But let's go through it by hand. Let's get an appreciation for what it does, and hopefully you'll see what happens. Okay? All right. So let's go ahead and do this. I'm going to do this on 2 different sets. And they're going to seem sort of silly, a little bit sophomoric, but bear with me, and this is so easily extendable to, I'm going to change colors here, to any data set of any size. So here we go. Let's just say, I'm not even going to try to come up with a way to justify this data. Let's say that it's 2, 4, 6, and 8, 10, 12. All right, so we collect data, and this is the data that I get, and we order it because we're looking for quartiles, and we're looking for medians, and we're looking for all that good stuff. All right, so this gets real simple. I'm going to do Q1 is equal to 2. Q1 is equal to 2. Try that again, ding dong. Let's try the min is equal to 2. It's good to see your instructor make mistakes. The min is equal to 2. Now, let's get some freebies here for just a sec. I'm going to do Q1. I don't know what that is. I'm going to do the median. I'm going to do Q3. I don't know what that is. And I'm going to do the max. Now let's grab some freebies. The max in this case is 12. The median, now let's see, how did that work again? It's the physical middle of the data set. So it's going to be a value. It's going to be a value that cuts a 6 data size sample, an n of 6, in half. So it's going to live somewhere between the 3rd and the 4th data value. So it's going to be 7. If I took the average of 6 and 8, I would get 7. Okay, now watch how this works, because this is kind of important, and you'll see what happens when I tack on another data value. Think of the median, no matter where it lives, I'm going to remove it from the data set. So what I've done now is I've cut the data set into halves. And the reason that I do this is I have to find Q1. Now Q1 is really the median of the lower half of the data that's left over. So remember, 7 lives right here. So what I have is these 3 data sets. So the median of these 3 data values would be 4, and that is Q1. Same thing for Q3. The data that's left over to the right of the median or above the median, we just think of it as its own data set, and I find the median of that. So this would be 10. And that would be my 5-number summary. So if I wanted to do my box plot, oh wow, you guys are going to make me draw straight lines again, right? So this is going to be 2, 4, 6, 8, 10, and 12. Ooh, looks like I got a little overambitious in my box plottery. Let me change the colors. I do like changing colors. Sorry, guys. All right. So all I do is I put my min here. Q1 is here, and that's going to start my box. The median is at 7, so I'm going to put that guy right down the middle. Q3 is at 10, and and my max is over there. And I do this. I draw my little box. See how it wants to kind of make everything straight, but it just doesn't work. Now, look at this. Notice that the median is right smack dab in the middle of the box. And these whiskers, like I say, box plots are sometimes referred to as box and whisker plots. These whiskers are the same length. And that means that we have this wonderful symmetry in our data. So just by looking at the box plot, in absence of the data, if I didn't have the data sitting in front of me, I could go, oh, median's in the middle, whiskers are the same length. Guess what? We've got at least approximate symmetry. I don't even know, by looking at the box plot, I don't know that n is equal to 6. Okay? Now, I'm going to show you what happens if n changes. I'm going to make n equal 7 and watch what happens. Okay, so again, I'm going to change here. I'll make it green, and I'm going to make this guy 20. And I think this will help kind of show you. It'll give you an example of what you can mine from a box plot. All right, so same thing. We're going to go min. We're going to go Q1. We're going to go let's go median. Sorry about that. We're going to go median. It's really hard to write on something where you can't see what you're writing. I'm writing on a tablet, and clearly I don't write anything on my tablet, so it's kind of hard to see what's going on. Okay, so you ready? We grab our min is the same, it's 2. Our max is a 20. Now let's look at our median. Now notice, now I've got a sample size of 7. So if I'm going to cut this thing in half, I'm going to find the value that makes it so that half of the values are below that value and half of the values are above that value, then 8 is my median now. Now, let's make sure we all understand why that is. There are 3 data values below 8. There are 3 data values above 8. Now watch what happens to my first quartile and my third quartile. Well, my first quartile is the median of the data below 8, which is 4. Same as before, but now Q3 is at 12. See, it pulled that thing over. And let's see what happens when I throw this bad boy on a box and whiskers. Now, I'm not going to mess around this time. Let's go 2, 4, 6, 8. Wait, Ripley, what are you doing? My gracious. Let's try to maintain some semblance of scale. 2, 4, am I going to have enough room? 6, 8, 10, 12, 14, I am, 16, hallelujah, 18, and 20. All right, so this just tells me what my numbers are. Now I know that my min is at 2, so I put this guy right here. I know that my box starts, let's keep it kind of pretty, starts at 4 because this is always Q1, right? My median is 8, so I think I put 8 right there, didn't I? This is my median. This is my min. Let's see, Q3 was at 12. So this is Q3. And then my max is all the way over here. So watch what happens to my box and whiskers. So it's kind of hard to see because you know what's going on. But look, now I've got this big old whisker over here. By the way, this is my max. I've got this big old whisker over here. So that tells me just by looking at the box that I'm probably going to have a right skew. I'm going to have what appears to be an outlier right way over here at 20. Again, I don't know what the data looks like. I have no idea. Let's assume that we can't see it at all. All I see is the box plot. But because of this really long whisker, that tells me that I'm probably going to have a right skew in my data. It also means that the mean is going to be above 8 because this maximum value is pulling the mean away from the median. Now, the cool thing about a box and whisker graph, really it's the 5-number summary that gives this to us. There is a way to determine an outlier. There's sort of a standardized way to determine an outlier. Excuse me. It's actually really simple, but we need a little bit of terminology first. We need something called an IQR, which is interquartile range. Again, with all this vocab, you might want to throw it on cards, just, like flashcards like you would with any other vocab. And the interquartile range is always just Q3 minus Q1. Now, statistically speaking, the unit standard for an outlier is this. If I take Q3 and I add 1.5 times the IQR, if I get a data value that is greater than this, then this is considered an outlier on the top side. So that would be like this. If I add 1.5 times the IQR and I add it to Q3 and I get a data value that's bigger than whatever that number is, that's an outlier. Similarly, if I take Q1 and I subtract 1.5 times the IQR and I get a value that's less than that, then this is considered an outlier. So let's go through this real quick. I'm going to change my color. I like changing colors. Let's find the IQR first. So I go IQR. Let's determine if this 20 value is indeed an outlier by this new method of calculating. So IQR first and foremost is just 12 minus 4. 12 minus 4, which is 8. So if I go 1.5 times 8, what do I get there? That's 12, right? Which implies, let's see, Q3, what was Q3? Q3 was 12, so this implies that 12 plus 1.5 times 12, or excuse me, times 8, which is also 12, is equal to 24. Now, our biggest number is 20. Because 20 is not greater than this, even though it appears as though 20 may be an outlier because it gives us that real long whisker, this is not an outlier. It's not an outlier. It wouldn't be an outlier unless it were greater than 24. All right? Now, let's do it on the other end. If I go, let's see, my IQR is 8, right? So if I were to go Q1, which is 4, minus 12, which is negative 8, now what I need is a value that is less than negative 8 to qualify as an outlier. Well, since my lowest is 2, it's clearly not an outlier, which I think intuition told us as much, okay? So it's not, it wouldn't be an outlier unless it were less than negative 8. And since we don't know what our data is, it's entirely feasible that we could get values that are negative, all right? So that's a really wonderful way to use statistics to be able to determine some stuff without even looking at the data. These distributions and these graphs are really great, and they show up everywhere, and they look intimidating, especially if you don't know what you're looking at, but like 2 laps with them, 2 reps with them, and it's like, I got this. This is not very difficult. All right, but you are going to have to know your vocabulary or else you're going to run into some trouble, because I'm going to throw out things like interquartile range, percentiles, variance, standard deviation, et cetera, and you're going to have to be pretty fluent in those terms. All right, well, thanks for paying attention. I hope you enjoyed Chapter 3.